Welcome to this video tutorial on quadratic regression. Now, quadratic regression is pretty straightforward, so hopefully you just remember how to do regression on your calculator. And in this problem we have a baseball type scenario where a ball is being hit and it flies and lands once it goes through the air. We're going to take our calculator in order to analyze this problem. First we're going into stat, which is in the middle of the calculator, and we want to edit our list. We're going to use the data in the problem. So 1 second, 2 seconds, 3 seconds, those are our L1 or X values. 44 feet, 51 feet, and 26 feet. Those are the Y values for the height, which we will put in L2. Once those data are in the calculator, we quit second mode to go to the home screen. We go stat. We want to calculate, and we want to calculate the quadratic regression, item 5. Our X is in the L1, so I go second 1 for L1, comma, the Y is in L2, so I go second 2 for L2. Hit enter. Now hopefully your calculator also displays the R squared. If it doesn't, here's how you fix that. Go second 0 to get the catalog. Scroll down until you get to diagnostic on. Hit enter, and now that will appear. So if I go second enter, it cycles through what I've typed, and there we have it. Now we analyze the output. So we want the height as a function of time. In this case, it'll be negative 16t squared. Notice it tells you that the negative 16 is next to the variable squared. Plus 55t, that's the b is the variable, or the b is the number next to the variable, and then just plus 5. Also notice that since r squared is equal to 1, that means that r is equal to 1, which means it's a good or even perfect fit for the data. Part B, we want to determine the maximum height the baseball reached. Let's go back to the calculator. I'm going to type in the equation that we have, but we have to use an x when we go in the calculator. So negative 16x squared plus 55x plus 5. The window. Now x is how long the ball was in the air. It's probably not going to be in the air for more than, say, 6 seconds. How tall does it get? Probably isn't going to get much taller than 125 feet, but the window is a little bit of a guess and check. Think logically and then modify as needed. We hit graph. There's our picture. We want the maximum height, so we second trace to calculate. Option 4 for the maximum. Left bound, I'm going to type 0.5. Remember, I don't like to scroll, but I can just hit numbers in there that work. For the right bound, I'm going to hit 4. And for the guess, I'm going to say 2. Notice there's our answer correctly. So here, the maximum height is the Y value, which would be 52.27 feet, correctly rounded to 2 decimal places. How long it took to reach the maximum height, that is the X variable, which in this case would be 1.72 seconds. And for the last problem, what if the ball landed 20 feet above the ground in the bleachers? We go back to our calculator, go into our Y equals. We're going to include now Y2. We're going to include now Y2 is equal to 20. And when we go to our window, we really need to see the Y value of 20. So I'm going to change this, make the Y max 40, hit graph. We want the intersection when the ball is falling, not when the ball is taking off. So we go second trace to calculate the intersection, which was option 5. Enter, enter. Make sure the guess is near that intersection point. Hit enter, and there it is. So for this problem, we see that this is our X value, that's the time, and it would be about 3.14 seconds. 3.14! Easy as pie. And that's all there is to quadratic regression.